Okay, so 20 times 80, 1600. The same. Next, I'm going to take the Y bar. And I'm going to take the Y bar from the top. From the top means I'm taking my datum from the top where I'm finding the centroid. So this is equal to 20 divided by 2. This is 10. This is 20 plus by 80 divided by 2. So 20 plus by 80 divided by 2 is equal to 60. Likewise, this is also equal to 60. And then from here, you multiply omega d Y bar. So 320 times 10. 32,000. 60 times 1600. 96. Let me make sure everything is correct. Okay. Then we take the summation. And then we take the summation again. Then finally, our Y bar is equal to 224,123 divided by what? Okay, so 24123 divided by 64. 35. From top. Anyone, any question? Did I make a mistake or we are okay? We're okay? Are you okay? You're standing up. Did I make a mistake somewhere or we're good? Okay. So we know our centroid is 35 millimeters from the top. Okay. So we want to find the shear stress at point A. Okay. So the shear stress at point A is equal to Vy over what? Izz Qz divided by what? Divided by T. Okay. So how to find your first moment of area? The first moment of area is from the what? From the center, from the Y max, right? So this over here, because A is on top, this is your analysis direction. Over there, that is your analysis direction, because over here to here, this is your what? Y max. We apply the rule, okay? So from here, we can start sketching how the shear flow look like, okay? So the shear flow look like this, okay? So this is how the shear flow look like. So we know that this is what? This is a constant, okay? So at A, QZ, okay, to find at A, QZ is this entire area over here. Okay, QZ at point A, I do apologize. QZ at point A. Okay. So when that's the case, I usually like to go by width, depth, Y bar. Okay. So the width is 160 or 0.16. The depth is what? 0.02. The Y bar is equal to what? 0.035 minus, okay, 0.035 minus by 0.02 divided by 2. Why 0.02 divided by 2 is because over here, I'm drawing in green now. The distance from here to here, okay, this distance is equal to what? this distance is equal to 0.02 divided by 2. Okay, so this is your width, this is your depth, this is your y bar. So from here, we get 0.035 minus by 0.02 divided by 2 times by 0.02 times by 0.16 is equal to 80 times 10 to the power minus 6 meter cube. Let me do it again. Yep, 80 times 10 to the power minus 6. So therefore, here xy at point A will be equal to Vy over Izz. We don't care about those values first, but more important is equal to what? Qz is 80 times 10 to the power minus 6 divided by 0.02 multiplied by 2. Okay. So this will be equal to Vy over Izz. Okay, so 80 power minus 6 divided by 0.02 divided by 2 is equal to 2 times 10 to the power minus 3. Okay. Now, you don't use this value. Okay, what I'm showing you is the wrong thing. Okay, this part is where this side is the wrong one. Vy over Izz multiplied by 80 times 10 to the power minus 6. Then I'm going to divide by 0.16. So this is equal to what? 80 of 6 minus 6 divided by 0.16. So this is equal to 500, or this is equal to 0.5 over Izz. 0.5 times 10 to the power minus 3. I'm going to copy that image over here. I'm going to put over here. If you look at point A, listen to me, don't talk. I know you. Listen. Okay. At point A, there's two thickness. Yes or no? One is at 0.16. The other one is twice of 0.02 times 2. Yes or no? Right? Why we don't take the 0.16? Anyone? And it's not very complicated. Anyone says, why do we take the 0.02 twice and not the 0.16? Yeah. Say it again.
It's gonna fail.
Yeah. It's not just, yeah, it's going to fail. Well, then it's going to fail in a thinner section. And what's the point calculating something that will not fail? We clear. Nothing to what? Memorize. It's all about what? Common sense. Are we clear? So we don't take 0.16. If you look at those two values, okay, if you look at those two values, okay, you look at those two values, right? If you look at on the right hand side, which the thickness is at 0.15, the Q over T is what? 0.5 times 10 to the power minus 3. The one on the left is what? 2 times 10 to the power minus 3. Okay. So you calculate the what? The higher value. Don't report the lower value. Lower value will not fail your structure. Now, the next thing we want to do, which is really, really interesting, and I want you to apply the rules, and this is where the fun begins. We are going to calculate the shear stress at point one, at point B. At the first moment of area we're going to take. Okay? And we are going to apply the rules. We're going to apply the rules. we're going to apply the rules. Okay? Now, I'm going to ask you all a question. You're going to tell me, is it right or wrong? Then I'm going to ask you a question. Okay? And this is, I want you to apply the rules. Okay? Now, I'm going to, this is where it's fun. I think it's fun. Some of you might call me sadist, but it's okay. I think this is fun. Now, if we want to calculate this, do we take this as our first moment of area? If you look at the rules, what did the rules say? The first moment of area cannot cross the center. Yes or no? So this one is wrong. Right? We as mechanical engineers, this one is wrong. We as mechanical engineers, we are very visual. You will ask yourself, Eugene, why this is wrong when you say that the shear flow this way? Yes or no? I should take the area. Oh. So Eugene says that I cannot cross the first moment or the centroid. Then can I do this? Okay. What if we do this? What is this correct? Okay, sorry, is this correct? What rule did we break? Yeah. Yeah. So what happens now is this. Okay, this is wrong. Is because the analysis starts from what? Analysis starts from what? Y max. Yes or no? The analysis has to start from Y max. So there are two positions of Y max. This is your first position of Y max, and this is your the other position of Y max. So the analysis from below, or I call it bottom, and this is the top. At the top, the analysis has to start from here. At the bottom, the analysis has to start from there. Head looks like this. The area that we're going to take is this area. And over here, this is our centroid. Did we break any of the rules? Rule number one, B and Y are what? Or B and I are what? Constant. Rule number two, the data is at the what? Centroid. Rule number three, is it analysis start from Y max? Rule number four, the first moment of area cannot cross the center. Only with this, okay, this topic is very easy. Okay, only with this, you apply all these rules, then you know what area to take. If not, you get really lost with your what? With your area. Okay, so let's see what is the area. Okay, so now we want to find okay, so hey, hopefully it works. Yeah, thank you. You need got this blipping red line. So now we are going to get right. So we know that this is 35 millimeters. Right? So from here, we know that our Q Z for point B, so it's going to be twice because you have what? Left and what? Right? The width is what? 0.02. The depth, the distance from here, the depth is equal to 30, 0.03. And then the Y bar, because we know that this is 65, the whole thing is 100, and this is what? 30 divided by 2. So it's equal to 0.065 minus by 0.03 divided by 2. So this will be equal to 0.065 minus by 0.3 divided by 2 is equal to 60 times 10 to the power minus 6 meter to the power of 4. Wait. Yep. Okay. I'm going to stop here. I see you all later at 12:30. Yes. Because the datum is from the centroid. So anything away is going to be positive.